Have you ever really thought about a playground swing? I mean, it seems so simple, right? But that easy back and forth motion is actually hiding a really cool physics puzzle. So let's dig in and see what's really going on here.
It all comes down to a question that every single one of us has probably asked as a kid. If you get a really good push, why does the swing eventually stop? It feels like it should just keep going forever, doesn't it? Well, it turns out there's a kind of invisible force at play, and today we're going to figure out exactly what it is. All right, so to solve this mystery of the slowing swing, we've got to start at the very beginning. See, before we can figure out why it stops, we first need to get a handle on what makes it go. And the answer to that, in one word, is energy. The movement of a swing is really just a beautiful dance between two basic forms of energy. So let's meet our two main players in this story. And here they are, potential energy and kinetic energy. Just think of them like two partners constantly trading back and forth. To really get what's happening with the swing, we need to understand how these two work together. So let's break them down one by one. So first up, we have potential energy. Now that's just a fancy way of saying stored up energy. And the key thing to remember is that it's all about position. When you pull a swing way back and hold it there, right at the top of its arc, for that split second, it's packed with the most potential energy it can have. It is just ready to fly. The second you let go, all that stored up potential energy starts turning into our second type, kinetic energy. And kinetic energy is simply the energy of motion. As that swing comes swooping down, it picks up speed, right? And its kinetic energy builds and builds until it peaks right at the very bottom. That's the point where it's moving its absolute fastest. And then the whole cycle just repeats itself. As the swing zips past the bottom and starts climbing up the other side, it starts to slow down. That kinetic energy, the energy of motion, gets converted right back into potential or stored energy, getting ready for the next trip down. It's this constant, graceful trade-off, back and forth, between moving and waiting.
Okay, but hold on. This brings us right back to our big question. If all the energy is just switching between potential and kinetic back and forth, then why doesn't the swing just go on forever? The physics seems perfect, but something's obviously missing from our little equation. It's like there's an invisible thief out there slowly stealing the swing's energy.
And you know what? That energy thief actually has a name. Friction. That's it. It's the invisible force that's been working against our swing this whole time, quietly stealing a little bit of energy with every single pass. So where is this friction actually coming from? Well, it's attacking the swing in two main ways. First, you've got mechanical friction. That's the squeaking sound you sometimes hear, the metal chains rubbing and grinding against the metal hooks at the top. And second, you've got air resistance. I mean, the air itself is pushing against the person and the seat, acting like a giant invisible brake. But here's the really important part. Friction doesn't actually destroy the energy. That's like a fundamental rule of the universe. It's impossible. Instead, it does something that's kind of like a magic trick. It just transforms the energy of motion into something else entirely.
And that something else is thermal energy, which is really just a scientific way of saying heat. Every single time those chains rub together and the air pushes against the seat, a tiny, tiny bit of the swing's useful motion gets converted into useless heat. You can't see it, you probably can't even feel it, but it is happening constantly. So let's just walk through the whole process one more time. We start with the swing's mechanical energy. That's the whole potential and kinetic cycle. Then, friction steps in and creates resistance. This resistance transforms that useful energy of motion into thermal energy, or heat, which just kind of drifts away. And because a little bit of energy is lost on each swing, the motion has to get smaller and smaller until it stops.
What we've just uncovered here isn't just the secret of why a playground swing stops. We've actually stumbled upon a demonstration of one of the most fundamental laws in all of physics.
And here it is. It's often called the law of conservation of energy, and it's one of the most important rules in the entire universe. But it's also beautifully simple. It just says that energy can't be created and it can't be destroyed. It can only change from one form into another.
So here's the bottom line. The energy that was making that swing move isn't gone. It didn't just vanish into thin air. It was simply transferred. It made the air around the swing and the metal hooks at the top just a tiny, undetectable bit warmer. The total amount of energy in the universe stays exactly the same.
And that kind of leaves us with one last thought. This whole principle isn't just for the playground. It is happening everywhere all the time. It's why a car's brakes get hot when you stop. It's why rubbing your hands together makes them warm. Now that you know what to look for, Where else can you spot energy making one of its amazing transformations?